We're doomed, we're saved.
The Biorevolution podcast.
Your host, Luise von Stechow
And Andreas Heuchler.
Maybe one other area we could briefly talk about where we already now see really a lot of real impact of LLMs. Beyond this extracting information from text, I think is the other area of like exploring very quickly a large option space in a slightly better way than we could do before.
Yeah.
And I think here the area of applying LLMs not just to human text but to DNA to generate potentially new proteins. I think that's a super interesting area.
Yeah, that's for me. I said it in the last time we spoke about it as well. That's by far the most interesting, the most exciting area that I can think about to apply this because, I mean, as you said, we want to not trash talk the LLMs, but I will say, I mean, you still sometimes feel it's like a glorified Google search. Which it isn't. It's much, much, much better and complex than that, but still. But for this kind of application, I think there is the chance to create something new that humans cannot create because they cannot read the molecular language. And the LLMs can, to a certain extent, have, again, I say understanding. I don't mean understanding. They have a memorization capacity to familiarize themselves with the languages of molecules. And that can be, of course, the code of DNA, 3 billion sequences, I think, the human genome, which consists just of 4 letters. So it's really like a binary code, basically. And then we have proteins, which are made up of 20 amino acids. And then we have also chemical molecules, which can be read in this so-called SMILES language that basically linearizes chemical molecules. And apparently the LLMs, especially I think for DNA language, seem to be pretty good at learning this language. And of course for human, I mean, you can sit there and read A, G, C, T, 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 but it will not tell you anything. And also, right. I mean, I know some like academic researchers who look at a sequence of DNA and say like, yeah, but here is the promoter. I don't. But of course, the large language model, given that it can process so much information, can do that. And this is still, for me, still super exciting, I have to say.
Do you think LLMs hallucinate less when it comes to molecular language, or is it just the same?
I would say it's just the same. I think it's just really the problem of the model. I also don't know if they hallucinate more. I actually don't know. It's a good question. I would not be able to answer that right now. I think the language is a little bit different. I mean, the human language is more structurally implicit through the grammar. And the molecular language has some other factors. So, I mean, we have this sequence of DNA, but there's also structural information entailed in this sequence. And the model doesn't know, or probably does not know, very likely does not know implicitly what, on the one hand, I mean, within this sequence of DNA, it tells how the DNA itself folds, because the DNA itself is also not lying around flatly. It's like a really complex molecule. I mean, it's really coiled and wound around proteins and doing a lot of stuff. And this also is important for the regulation of the DNA, because bringing 2 sequences that might be very dispersed together will lead to their activation. And then it also holds the information for how the RNA that is based on that will fold, and the proteins that are based on that. So basically you have 3 levels of structural information within this sequence that we don't understand. And this is, I mean, that was the big question, right, around AlphaFold, which was this huge success for DeepMind, where they said they solved the protein folding problem. It's super good, but they didn't solve the protein folding problem because we still don't know which sequence will fold into what. It's, again, just memorizing a lot of data and then getting very close to predicting the right thing. But it does not have the knowledge of the world, of the DNA.